In this video, we'll be taking a look at z-scores. Z-scores precisely identifies the location of scores and subjects in a distribution. You can find information in our book on z-scores on pages 171 to 178. If you do not have the book, just continue with the video to find out all you need to know about z-scores. What do you do when you want to locate a person very precisely in a distribution? For example, our jump rope person, compared to another person, for example, our sports casualty person. Or you want to compute some statistics on two measures that are very different. For example, scores on the Medical College Admissions Test, or MCAT, and grade point averages, or GPA. Z-scores to the rescue. A little known fact for you trivia buffs. Don Diego de la Vega, also known as Zorro, left his mark on other clothes, the sword slash of the Z, and left his mark on math with the invention of z-scores. We like to impart these interesting bits of trivia as we go along. But what are z-scores? Essentially, they're the same as the standard distribution we just covered in our last video. So here's a normal curve, and pop. There are the standard distributions. Now another pop. And there are the z-scores. Note that standard deviations and z-scores are the same value. The difference is this. Standard deviation are always expressed relative to the mean. So you can be 1.85 standard deviations away from the mean or 2.38 standard deviations below the mean. Z-scores are scores points. So you can have a z-score of 1.85 or 1.85 standard deviations above the mean, or a score of minus 2.38 or 2.38 standard deviations below the mean. It is semantic difference. What do you need to get a z-score for any subject? You need the subject score, you need the mean of the distribution the subject score came from, you need the standard deviation of the distribution and subject score came from, you need the z's formula. And there it is. X is a subject score, X with a bar over it is the distribution mean. The S sub X is the distribution standard deviation. Let's work an example. On the chemistry test you just took, the mean was 68.35. The standard deviation was 7.83 and your score was 91. Your z-scores is 91 minus 68.35 divided by 7.83, which gives you a z-score of 2.8927 or 2.893 rounded. Your z-score of 2.893 means you are 2.893 standard deviations above the mean, or pretty close to the top of your class on the chemistry test. A friend of yours in the same class made 76 on the exam. His z-score is his score of 76 minus the test mean of 68.35 divided by the test standard deviation of 7.83, which gives a z-score of 0.977. Your friend then is 0.977 standard deviations above the mean and exactly 1.916 standard deviations below you. When you can locate somebody in distribution to 3 decimal points, that is pretty precise, is it not? How about the MCT, AT, and the GPA problem we mentioned? MCAT scores are intervals and run from 472 to 528. GPA is ratio and runs from 0.0 to 4.0. So two different scores, interval and ratio, have very different ranges in values. So you have an MCAT score of 511 and a GPA of 3.2. For the year you took the MCAT, the mean was 500 and the standard deviation was 10.4. At your college, the mean GPA is 2.67 and the standard deviation is 0.58. Can we get your MCAT and GPA scores on the same scale? Yes, the Z-scale. Thanks to good old Don Diego. It goes like this. Your MCAT score is equal to MCA score of 511 minus a score of 500 divided by the standard deviation of 10.4. or a z-score of 1.0576, rounded to 1.054. Your GPA z-score is your GPA of 3.2 minus the means of GPA of 2.67 divided by the standard deviation of 0.58, or a z-score of 0.91379, rounded to 0.914. Why is this useful? Down the road, we will see that the Pearson correlation is the average of the cross product of the paired z-scores. For you, that would mean your cross product would be your MCAT z-score times your GPA z-score, or 1.058 times 0.914, or 0.967. You will now have to wait until you get to a Pearson correlation to see the played out in full. We know you're feeling that anticipation, excitement, but try to contain yourself. Thanks for watching Z-Scores, and please check out our YouTube channel for more videos on statistics and research methodology.